So, we continue with our studying of interaction effects in multiple regression. This is part 2, and now we study the case of dummy times dummy. So let's now use some recent Icelandic survey data to address a few issues. First, we're going to address the effect of educational degree on subjective social rank. So subjective social rank is basically a measure of how individuals place themselves on the social ladder, from where you can have 10 points ranging from 1, which is the bottom, to 10, which is the top of the social ladder. We're going to address the effect of traditional gender on subjective social rank, and we are going to study the interaction of education and gender in influencing social rank. So like this, we're going to ask, does the relationship between education and subjective social rank, does it depend on gender? Is it contingent on gender? Is it moderated by gender? So the variables that we're going to use come from the International Social Survey Program, which is focused on social inequality for Iceland. The survey is conducted in 2020. We have dummy variables for educational degree. So we have less than college for reference. We have a dummy variable for which I call college basic, which are people with bachelor degrees. We have another dummy variable for college graduates. And again, the reference category are individuals who are less than college. So 2 dummy variables representing a 3-category nominal variable. We have traditional gender, using males for reference. And the dummy variable that I use here is called female, and it's coded 0 and 1. 0 are males, and 1s are females. Finally, we use the variable social rank, which is the individual's self-placement on a 10-point scale, where the respondents are asked, where they place themselves on the socioeconomic ladder. So those who say 10, they think of themselves at the top of society's social ladder, and those who say 1 think of themselves at the bottom. And we're going to be arguing that both educational degree and gender, and the interaction between education and gender, influence social rank. Now this would be the additive model. In this model, we are saying that education, having a college basic relative to less than college, having college graduate degree compared to less than college, and being female rather than male, that the effects of these dummy variables are independent of one another. That would be the additive model. So in this model, beta 2 is the mean difference in social rank between individuals with bachelor degrees and individuals with less than college degrees, while controlling for gender, right? This is the additive model. But the non-additive model has two multiplicative terms. First, we need to multiply college basic with female, which is college basic times female. That's a variable. And second, we need to multiply college graduates and female. So we're multiplying together the dummy variables representing education on the one hand, and the dummy variable representing gender on the other hand. This will give us 2 multiplicative interaction terms, because one of the dummy variables has 2 categories. Now, we need to be very careful in interpreting the coefficients in this model. So, and I will explain the logic on the next slide, but let me just state beta 2 here will be the mean difference in social rank between males with bachelor degrees and males with less than college degrees, right? So again, as always, the coefficient for a dummy variable is the difference between two groups, the mean of two groups on the dependent variable. But because there is a multiplicative interaction term, there is a condition. There is a condition. And the condition is whether you're male or female. So this coefficient only applies to males. The coefficient for females is different. Another example from this equation, and likewise, just to finish all interpretations, beta 3 would be the mean difference in social rank between males with college graduate degrees and males with less than college degrees. It only applies to males because there is a condition. And here's the condition. Okay. The coefficient for female, this is the difference in social rank between females and males, but there is a condition. And the condition is education. And this coefficient only applies to those who are less than college degrees. And I'll show you that in the next slide. So beta 4 is the mean difference in social rank between females and males with less than college degrees. Beta 5 and beta 6, these are the interaction coefficients. So we'll be looking at if these are significant or not. And beta 5 indicates if the mean difference in social rank between bachelors and less than college is different between females and males. Does education have different effects for males and females? This coefficient will tell us that. If it is significant, then we can conclude that the difference between college basics and less than college is different between males and females. Likewise, beta 6 indicates if the mean difference in social rank between graduates and less than college is different between females and males. So is the effect of education on social rank different between males and females? If this guy is significant, well, that indicates that that the difference between college graduates and less than college in terms of social rank is different between males and females. How so? Well, let's write up the basic equation here again. This is the non-additive equation. So let's see what the equation looks like for males and then for females. Start with males. Look, if we want to see what the equation looks like for males, we simply plug in 0 for female. So that will give us this college basic will be, this part of the equation is unchanged. But beta 4, this is the effect for female, that gets a 0. The interaction term college basic times female, well, that'll become college basic times 0 because males have 0 on female. And this interaction term will be college graduates times 0 because males get 0 on the variable female. And so that will simplify the equation to this. So the effect of female and the two interaction terms disappear because all males will get 0 on these three variables. So what's left is beta 1 plus beta 2 college plus beta 3 college graduates. So this is the equation for males, right? This is the effect of education for males. What about females? Now we plug in 1 for female. All right. So so the variable here is female, right? Beta 4. Well, that gets a 1. The former interaction terms will be college basic times 1 because females get 1. And the second interaction term will be college graduates times 1. College graduates times 1 because females have 1. And that will become this. So we have this equation, right? Because we had times 1 here. And that simplifies to beta 1 plus beta 4, that will be the intercept for females. Beta 1, beta 4, right? And the coefficient for college basic, well, we add this coefficient, beta 2, and we add beta 5. We add beta 2 and beta 5. These are the coefficients for college basics. So beta 2 plus beta 5. And then we do beta 3 plus beta 6 for college graduates. And so the equation for females will be this one, right? So what's added to the equation for females is beta 4 will be added to the intercept, beta 5 will be added to the coefficient for college basic, and beta 6 will be added to the coefficient for college graduates, right? So let's see how this works with data. This is premature. I'm going to open the SPSS now. Okay. So we are going to be working with this example here. This is actually the example from the dummy variable lab session, where we had social rank, which is variable number 41. This is placement on a 1 to 10 scale, social letter scale. We create the variable female from sex. So the variable female is coded 0 for males and 1 for females. We created a variable, we use the variable degree, which has 7 categories originally, but we treat it as a 3-category nominal variables. So individuals with less than college, individuals with bachelor degrees or college basics, and individuals with graduate degrees. And we create 2 dummy variables representing college basics or those with bachelor degrees, and another variable representing college graduates. And the reference group here are individuals with less than college degrees. Continue. We're going to, at some point in the exercise here, we're going to control for job status, and the reference category here are those who are working. And I created a dummy variable for students, those who are disabled, those who are retired, and other, including unemployed, homemakers, and other groups. Right? So I will add this in the final equation. So we could let's run, I'm just going to run all these variables here. I actually did it before, that's okay. So now we have the variables. And let's just go to regression and just start off by, just to show you, here is social rank dependent. And I'm just going to run the regular additive model first, like that. So yeah, I already have it here, so I'm just going to run it. This is just social rank regressed on the 3 dummy variables, 2 dummies for education and 1 dummy for gender. And here we get the additive model here, right? And we can see in the additive model, this is the model that we've seen before in the computer lab. So we see that college basics have significantly more, or have significantly higher social rank than less than college, right? And we see that college graduates have significantly more social rank than less than college. And the difference between college graduates and that less than college is about 1 point on the 1 to 10 scale. And this model also shows that females, although they have, a little bit of a less score on social ranks than males, that difference is not significant at all. So there's no significant difference between males and females. But it could be that the difference, that education has a different effect on social rank between males and females. That could be, though. And that's what we're going to test next. So let's go to the output here. I need to create 2 interaction terms now. I'm going to create an interaction term for college basic times female. So I've already done that here. So you just write compute, and then you name the variable. You can call it whatever you want. I always just use this scheme here. I just write college basic and do an X, a large X, referring to times female, and then the function is equal, and then I write the name of the variable college basic, and I do a asterisk for times, and then female, which is the name of the second variable, and then a period. And if I run this command, I will create a new variable which will be the multiplication of college basic times female. And I do the same with the graduates. So I create a variable, I'm going to call it college graduates times female, and the function is equal to college graduates times female. This is the name of this variable, and this is the name of this variable. So if I run these two, I get two new variables, and now we can add those to the equation. Again, let me just show you what we're doing. We are estimating this model, and I just created college basic times female and college graduates times female. These are just new variables that I'm going to add to the model, the multiplicative terms. Let's do that now. So we need to add female, and we need to add the interaction terms. Okay. So here I have the equation that I wanted to estimate, the non-additive model. I run it, and here are the estimations, right? So R square is low, it's about 0.08, 8% explanation in the dependent variable, which is not a whole lot. But we're never going to get a high R square using only dummy variables. So what do I see here? I see an intercept of 5.7, and I get 1, 2, 3, 4, 5 coefficients. And now we can go to the PowerPoint. I have taken this information and put it in equation form. We can also see that only 2 of the 5 variables are significant. So only the variables college basic and college graduates are significant. But we need to examine what that means. Okay. So here are the final results. And let's move. Yeah, here's the final result. So I've listed the effects. This is the intercept, 5.66, and the 5 coefficients, right? So let's go, and I put an asterisk for the significant effects, as you can see. Now let's move. So first, let's start with the intercept. What is the intercept? Well, it is predicted social rank for an individual that gets 0 on all the 5 independent variables. So who gets a 0 on all the 5 independent variables? Well, those with less than college, right, because they get 0 here and 0 here. And males, because they get 0 here. And they also get 0 here and 0 here, right? So we would predict that individual that has no college and is a male would get 5.66 on social rank. Now that's not an important finding. And as soon as we would add more variables, including age, the intercept would become meaningless anyway. So what does this coefficient mean? Well, this coefficient, again, let me show you a previous equation here. Let's just look at the equation for males. Sorry about this. So I told you before that beta 2 is the mean difference in social ranks between males with bachelor degrees and males with less than college degrees. Why did I say that? Because if we plug in 0 for males into the equation, we end up with this equation. So this is the equation for males. Beta 1, beta 2, beta 3. And this is why, when I interpret this effect, it only applies to males. Beta 2 only applies to males. So males with bachelor degrees have significantly higher social ranks than males with less than college degrees. So actually, in this equation, let's continue. And likewise, with this guy here, this is only an effect for males, right? So I would say that males with graduate degrees have significantly higher social rank than males with less than college degrees. Here. What about this guy? Well, we can see that the variable female has no significance, but this effect only applies to individuals with less than college degrees, because there is a condition. Okay? There is no significant difference between social ranks of females and males with less than college degrees. So you can see that the interaction terms, they sort of scramble the other coefficients because they create conditions. Now let's look at the interaction effects. First, this one. So the interaction between college basic and female was not significant. Okay? And what that means, although we see a positive number here, we would say there is no interaction here. Okay? The mean difference in social rank between bachelors and less than college is not significantly different between males and females. So the effect of college basic on social rank is not moderated by gender. Right? The other interaction effect, the other interaction term, is also not significant. Okay? And that means that the effect of college graduates on social rank is not significantly moderated by gender. The mean difference in social rank between graduates and less than college, this number here, is not significantly different between females and males. So, in short, there is no statistical significant interaction effect in this equation. And we might just as well go back to the additive model then. So we would conclude that there is no statistical interaction. But let's just spell out everything. What are the results for females and males? So what if we ignore the significance for now, let's just spell out the equations for males and females. What is the effect of education on social rank for males? What is the effect of education on social rank for females? Okay? Well, plug in 0 for female. Right? So we would get 0 here for female. We get 0 on this interaction term, and we get 0 on this interaction term because females... Oh, I'm sorry, I'm doing the equation for males. I don't remember if I said that correctly or not. So this is the equation for males. And males get 0 on female, 0 on female, 0 on female. So everything here becomes 0. And this will become the equation for males. Right? This is the effect for males. This is the effect for males. What about females? We plug in 1 for female. So this becomes active. The interaction term becomes active. And the interaction term becomes active because it's times 1. And we can plug in the numbers like that. And we end up, when I add everything up, you can look at the numbers, we end up with this equation for females. So the intercept is 5.62 and not 5.66. The difference, the mean difference between college basics and less than college is 0.64. and not 0.47. This is the effect for males, this is the effect for females, but the difference is not significant, right? The difference is not significant, we just found that out. And the difference between college graduates and less than college is 0.93, but for males the difference was 1.16, but this difference in the effect of being a college graduate on social rank, this difference is not statistically significant, right? But again, the equations are not significantly different for males and females. I just wanted to spell out what this means. You know, what does it mean to include these interaction terms? It means that we have different equations for different groups. And if we want to find out the equations for different groups, we can use this method. Just plug in the values for different groups, and then we get different equations for different groups. This is the equation for males. This is the equation for females, right? Now finally, as we are doing multiple regression, we are rarely content with just education in females. We would probably want to add more variables to the model. So let's end up doing that. So if I'm considering social rank, I probably would include age, because age is going to shape social rank, and many other variables would. I'm just going to include work status here. So I have 4 dummy variables for work status, in addition to all the other variables in the model here. And I can estimate that model here, right? And I just put it into the PowerPoint just to see. So here we have a more fuller model. We're predicting social rank. We have education degree, we have gender, we have the interaction between gender and education, and we control for age and work status. Right? And what do the findings tell us? Well, if I begin with the control variables, we can see that age has a positive effect, positive significant effect on social rank, controlling for education and controlling for gender, and controlling for the interaction of education and gender. Work status has the expected effects on social rank. So students have higher social ranks than working people, and the effect is significant, and this effect is controlling for age, gender, education, and the interaction of gender and education, right? One more effect, so those who are permanently disabled, they have a lot lower social rank, significantly controlling for age, gender, education, and the interaction of age and of gender and education, right? So this part of the equation here, age and work status, this part of the equation, these are just additive effects, right? So we can have additive effects and non-additive effects in the same equation. This is the additive part of the model. We interpret these effects as we always do. But this is the non-additive part of the model. Here we have conditions on college basics. This is the condition, college basics times females. We have a condition on college graduates. This is the condition here, etc. So if I'm going to interpret this coefficient here, this is the difference between college basic and less than college for males, only for males. So males with college basic have higher social rank, significantly higher social rank than males with less than college. Here, males who are college graduates have significantly higher social rank than males with less than college graduates. Female, there's no significant difference between the social rank of males and females that have less than college degrees, right? And here are the interaction terms. Well, because they are both non-significant, they indicate that the effect of education on social rank, or the relationship between education and social rank, is not significantly moderated by gender. It's not significantly moderated by gender. And maybe, it depends on what we would be doing. Maybe if the main focus of the study was this interaction effect, to show that education had to test if education had different effects on social rank between males and females, this would be the final model, right? But maybe I was just checking that out, and I really wanted to study I really was just generally interested in how education and gender are related to social rank. In that case, I might report the findings without the interaction terms to simplify them, right? Because the interaction terms are not significant. Depends on what the aim of the study is. Okay, so that concludes this video, and in the third video I will go on to the case of linear times linear interaction, the interaction of two continuous variables. I will do that in the third video, the interaction of two continuous variables.